Okay? So if it's simple harmonic motion means that your alpha is some amplitude, okay? A e to the I omega t, correct? Very good. Look at this equation. This is your governing equation, right? It's a linear equation. If you double alpha, the gamma will double. Okay? It's a linear equation. We're in linear flow anyway. So the linearity of the equation, when you have any linear system, you apply a sinusoidal input, there's some transient in the middle, you ignore it, but the steady state output will be what? So the steady state gamma, as a function of z and t, will be what? Will be also something oscillating with the same frequency. So this is, now we can make use of it. And here, this guy is a function of z, and maybe complex. Why? To create a phase shift, because there might be a phase shift. Okay? So this may be complex thing, unknown, I don't know it, but I know how it varies with time. It's also oscillatory with the same frequency. So this is oscillating with some frequency, this is oscillatory with the same frequency. But there might be a phase shift and amplitude. This will be taken care of in this unknown. Okay? One more thing. If I have this gamma here, gamma wave at some z and time t, since the gamma convects with the flow, moves with the flow, this gamma actually was here sometime before. Gamma wave at some b and t minus some time, right? What's the distance? If this is z and this is b, so gamma wave at z and t is gamma wave at some other location, say the trailing edge, and t minus what? Minus the time travel, the time taken to travel this distance, right? The time taken to travel this distance by uniform speed u is simply the distance divided by the speed. The distance is z minus b divided by the speed is u, correct? So now expand this guy in this way. So this is gamma wave bar at the location e to the I omega. The time is t minus z minus b over u. So take anything that does not depend on t and z. Take anything constant here. So this guy is a constant. This is the wake circulation at b and time 0. Okay, this is fixed number. E to the I omega b over u. Okay, this is again fixed number. So we have some number b, whatever, okay? E to the I omega t minus z over u. Okay? So we got the functional dependence on t and z from this. So let's do some, let's substitute here in this integral, in this thing. Let's give it a name. It's L over L quasi steady, right? So here it is. L, C is L quasi steady times this integral from b to infinity gamma wave. I will substitute gamma wave by this guy. So it's some constant e to the I omega t e to the negative I omega z over u times z divided by square root dz divided by the same b e I omega t e negative I omega z divided by u times z plus b over z minus b dz. So this allowed us here. I cannot work with this ratio because gamma wave is unknown. But now I can work with this integral, the ratio of integrals. This is an integral of z only, this is an integral of z only. Let's do just non-dimensionalization. So z is eta b, non-dimensionalized by the chord, by the semichord b. So this is actually integral from from 1 to infinity e to the negative I k eta. Eta divided by eta squared minus 1 d eta. I'll divide k in a minute. 1 to infinity e negative I k eta square root eta plus 1 eta minus 1 d eta. K is omega b over u. And what a luck is that this ratio, it has an analytical expression. Look at this. This is an integral. It's not each one alone. It's the ratio. So anyway, so this integral is an integral over eta between limits. So eta will go away, but it will remain as a function of k. K is the frequency. And the same here. It's a function of k. So this guy turns out to be a function of k, and this is our topic next time. This is Theodorsen function. It's a function of k. This is h1 2 of k divided by h1 2 of k plus I ho2 of k. It's in terms of Hankel functions. We have analytical expressions. This is this Hankel function, MATLAB. You can write it as Bessel. H of it takes this guy, takes that guy, and takes k. So you can compute Theodorsen function analytically in MATLAB. I will continue next time.